All righty then. Good evening, everybody. Welcome to Wednesday Night Rabbit Hole. I'm Joe Slick, your host, and I have with me Mr. Canuck. Hey, good evening, Canuck. How are you?
Good evening.
We had our little intro there for those people who could hear it. I don't know if who could and who couldn't after I got the thing to work. Oh my gosh. Sometimes we get these updates and it just mess up the technology, doesn't it? Nothing
Yeah.
seems to be in sync. But I'm getting better at it and figuring out, oh, yeah, I know how to quickly get into solving a problem here. Couldn't solve the video problem today. I just didn't plug it in. But that may change later on. Who knows? But tonight, the Panamanian connection to Colombia and the Panamanian plate and plate tectonics. For those who are on YouTube and Rumble, this discussion tonight will talk about the microplate of Panama, its implications on how it interreacts with the Cocos plate, the Nazca plate, the Caribbean plate, and how it was created and its future. And also some interesting things that we might deduce based on some of the earthquakes that we have studied in how they move through and how that pressure moves through, whether it be strain or the other, stress. I'm not sure, but what I do know is they get pretty good earthquakes down there, and a lot of them are offshore, and some of them are onshore. And it's interesting how that area is interacting with the rest of the plates. And yes, they do push up against North America or the North American plate, and also because of the South American plate going. So interesting in how it's affected by the Atlantic plate boundary and the Pacific plate boundary. So we'll discuss all these things tonight. Eden says Tunga is spiking. Well, of course. We'll see. Yeah. Anyway, Canuck, good evening. What do you think about the Panama before we get into too depth? What do you think about Panama and all that?
Well, it's an interesting place, not just because the Panama Canal is there, but like the stuff we're going to read about tonight, in summary, South America wasn't always connected to Central America. So, because of the Panama Plate, that's how South America is connected to Central America now. And because of that, it's connected to North America. So, if you actually wanted to drive from Alaska all the way down through to the tip of South America, that's where you'd have to go through is Panama to drive into South America, which is why they're building bridges and stuff down there in the Darien Gap. Because right now, this is from, I watched Chuck Holton. He lives in Panama. So I get all sorts of information from that. So he said basically right now you can drive to Panama, but it's pretty hard to like drive over into Colombia because it's only like crapo roads. It's not like a major highway. But once you get in South America, there's another major highway you can get on and drive all over the place. But that's why they're building bridges down there. That China started doing it. They were the ones that were paying for it, but that's kind of stopped now. So I don't know if it's ever going to be finished or not. But it's pretty interesting because once you start studying about the Darien Gap, where all the immigrants came across from South America in order to get up through Central America and then come up through, that's where it all is. So it's kind of an important spot, not just for tectonics, but all sorts of different things. And of course, you got the Panama Canal there too. Even though Mexico's talking about making their own, but that's another rabbit hole we won't get into tonight. Because Mexico wants to bypass Panama altogether, build their own canal. It's pretty crazy stuff.
All right.
Yeah.
I think that's exactly kind of how I see it too, bud. That's why when you suggested Colombia last time, sorry, I've got a bubble in my chest.
Yeah.
It really just kind of started to open up things. Whether or not you can drive one down to another, that's some people probably find that interesting.
Yeah.
I find it interesting how the plates are moving. So let me open up a page. And I'll let you the isthmus that changed the world. I'll let you read this while I clear this bubble in my chest. So let me add this, share this screen.
Oh, I'll have to bring it up.
All right. You can see it online here. My wife just came into it. Hold on.
Because I have it in the...
I can read this here. The Panama Isthmus that changed the world. This is an article from NASA, by the way. March 23 of 2008. 20 million years ago, an ocean covered the area where Panama is today, creating a gap between the continents of North and South America, through which the waters of the Atlantic and the Pacific flowed freely. Beneath the surface, two plates of Earth's crust slowly collided into one another, forcing the Pacific plate to slide slowly onto the Caribbean plate. The pressure and heat caused by this collision led to the formation of underwater volcanoes, some of which grew tall enough to break the surface of the ocean and form the islands as early as 15 million years ago. More and more volcanic islands filled the area over the next several million years. Meanwhile, movement of the two tectonic plates also pushed up the seafloor, forcing some areas above the sea level. Over time, massive amounts of sediment were peeled away from the Americas by strong ocean currents and fed through the gaps between the newly forming islands. Over millions of years, the sediment deposits added the islands until the gaps were completely filled in. About 3 million years ago, an isthmus, a narrow strip of land with water on either side, had formed, connecting South and North America. The formation of the Isthmus of Panama also played a major role in biodiversity, making it easier for animals and plants to migrate between the continents. For instance, North America today, the possum, an armadillo, and the porcupine all trace back to its ancestors that came across the land bridge from South America. Likewise, ancestors of bears, cats, dogs, horses, llamas, and raccoons all made the trek south. Scientists made this false color image of Panama using the data acquired from the February 2000 by the Shuttle Radar Topography mission. Remember when we had shuttles flying aboard space? The shuttle Endeavour. That's what was made. So
yeah, it's pretty cool.
It's pretty interesting. And right here is the Panama Canal, and right there also was where the water went through. And Canuck will bring that into you. Another article, Columbia's Climate School. State of the Planet, news the Columbia Climate School. Kevin Karjak from March 31 of 2014. The Isthmus of Panama out of the deep of the earth. As dates of geological history go, the formation of slender land bridge that joined South America and North America is a red letter one. More than once over the past 100 million years, the two great land masses have been separated by deep ocean waters. The narrow section of Central America that now unites them and is narrowest along the Isthmus of Panama changed not just the world map, but the circulation of the oceans, the course of biologic evolution, and probable global climate as well. The tortured product of diverse forces. Today's version of the isthmus was probably fashioned by the volcanism and movements of tectonic plates somewhere between 15 and 3 million years ago. A Cornelia Class, a geochemist at Columbia University, Lamont, researcher now based in Virginia Polytechnic Institute, are looking into one of the most mysterious forces at work of this natural construction state or site, the Galapagos plume. The plume is a long-lived hot upwelling of material from the deep earth that melts near the surface and is formed strings of volcanoes, both underwater and ocean islands. Coming from the Earth's mantle dozens of miles down, the still active plume is similar to hotspots of magma that percolate under Hawaii and Yellowstone. It is believed to have started with huge outpourings of lava some 100 million years ago under what was now the Caribbean, but due to mainly to the movement of the tectonic plates above, has since migrated far south and west into the Pacific to its current active location under the Galapagos Islands. Some 600 miles away, Gazel and the class are trying to help unravel its life story and its role of creating the land bridge. Usually, as such rocks were buried far below the surface or lie deep in the ocean floor, here they are sitting on more or less dry land, offering an unusual window into the process of the deep earth. And you can see nice pictures of these people looking at it. Yep. In the fall of 12, class of and Gazel hunted for rocks created by the plume in Panama's Zero Peninsula, which juts into the Pacific Ocean. Gazel, who grew up in adjoining Costa Rica, where identical rocks exist, specialized in studying this region equally at home, discussing melt fractionization chemistry or walking around with an 8-pound sledgehammer slung over his shoulder. He looks around for likely boulders to smash open. Class, a geochemist originally from Germany, is an expert in mantle chemistry. She works on rocks from East Africa, Antarctica, and the bottom of the Atlantic Ocean. People often try to understand far away things like how stars are formed, says Class. Actually, we should be looking much closer to home. Here we are trying to understand what's underneath us, how the earth itself was developed. And so that's the kind of what's going on with scientists who are interested in how Panama is created and what are the implications of how it affects everything else, whether it's climate, whether it's oceans or fauna or even animals. The development or the creation of Panama itself, I think, is pretty damn interesting because often we hear a lot about, the bridge from, Russia to the U.S., right? Alaska. We hear about that bridge all the time, man. All the people came over here, blah, blah, blah. Then we hear another one over from Iceland all the way into Europe, another land bridge there. But this is a land bridge that's not way up north. This is a land bridge that obviously is somewhere in the southern or central part of the earth around the equator. So I find that kind of interesting. Why the waters rose? Maybe not. Maybe not. Maybe just the crashing of land, smashing up against each other, created it all. And I think I'll turn it over to Canuck on the wiki.
So
I know he has that one ready.
Meekins relatives.
Say it again, bud.
So are the Mayans and the Incans relatives?
Yeah, that could be, huh?
Yeah.
They're all from China. You know that, right?
Yeah. Originally. Yeah. Well, the North American ones. For
All
sure.
right. So we're looking at the image, and you can do your comments and your what you thought about on the Panamanian plate,
Yeah. So now we're just going to do the
which is the pink area in the middle. Everybody.
Yeah, the Panamanian plate wiki. So I'm just going to read it out of there. Some of it's we've already heard already, but it's just going to be review and go a little bit deeper. The Panama Plate is a small tectonic plate, microplate, that exists between two actively spreading ridges and moves relatively independently of its surrounding plates. The Panama Plate is located between the Cocos Plate and the Nazca Plate to the south and the Caribbean Plate to the north. Most of its borders are convergent boundaries, including a subduction zone to the west. It consists, for the most part, of the countries of Costa Rica and Panama. So when we look up quakes later, we're going to do both Costa Rica and Panama. The Panama Plate is a southwestern extension of the Caribbean Plate, surrounded by 5 tectonic plates: the South American Plate, Caribbean Plate, Cocos Plate, and Nazca Plate, and by the Chordas tectonic block, which I'll explain later, because that's going to be the next one we do, probably the next episode. The plate had once been a piece of volcanic arc that split off from the rest of the Caribbean Plate between the late Tertiary and early Quaternary, and is currently moving in a northward direction. So this is important for when we do the quake stuff. The Panama microplate is bordered to the north by the Panama deformed belt and a diffuse thrust belt in the Cordillera Central of Costa Rica. So to simplify, it's the mountain ranges. That's what they're talking about. Because there's a whole bunch of mountain ranges in both Costa Rica and Panama. These thrust belts are being controlled by the active convergence of the Caribbean Plate towards Central America. The eastern edge of the Panama Plate is progressively conjoining with the continental plate of South America. So South America, and we talked about the North Andes Plate the last episode, that's all smashing into the Panama Plate. And Panama is attaching itself to South America, basically.
So is it accreting or is it subducting underneath? Or is it going over the top?
No, it's just accreted to it. That's basically what they say. And that's why it's moving north, because South America is smashing into it. Because South America is moving up, smashing into it, and that's why the Panama Plate itself is moving north, because South America is running into it.
Yeah, the Nazca Plate's going underneath the Andes Plate there in that area.
Yeah,
they're
the ocean plates.
And the Cocos is going underneath Salvador, Nicaragua, and all them.
Yeah, which is the Chordas block. All those other ones, Honduras, El Salvador, Nicaragua, part of Guatemala, right up to you get to the North American Caribbean Plate boundary in Guatemala. That's what they call the Chordas block, which we'll talk about more in the next episode, because all those are adjusting to what it's doing, both coming across the Caribbean and also coming up from South America, right? So what we're going to show tonight is what happens like after the big quakes happen in Panama and Costa Rica. What happens after that? That's what we're going to show tonight. Now I forget where I said it. Oh, yeah. The western expanse of the Panama microplate is characterized by deformation originating from the Tertiary and Quaternary linking the North Panama deformed belt in the east with the Middle America Trench in the west. Major changes in tectonic evolution exist across the Caribbean-Panama boundary, where three northeast striking faults intersect the Pacific coast. So in Panama itself, there's actually big faults that cut across, which I'm not going to go into in detail, but they're northeast to like southwest faults. So they cut across from like the Atlantic to the Pacific, basically, or the Caribbean to the Pacific. The Pacific side of the region is geologically active, with a narrow marine shelf exhibiting frequent volcanic activity and higher seismic activity, and the Atlantic side is more stable with a passive margin and broader marine shelf. So the plates always stick to the subduction side, usually. You
Yeah,
can
and in that in the image that we have here, where the 19 points, right, with an arrow, that purple goes over the top there. That's a convergent plate boundary, not a divergent. So what it's doing is it's uplifting. It's thrust faults, all right? And that's like Los Angeles. North of Los Angeles has that northeast, right? The section between Palm Springs all the way to Cajon Pass or Cajon Pass is that creation of the San Gabriel Mountains and the Pasadena Mountains and the Malibu and San Fernando and all that, because of all those thrust faults that we talked about back in September. The same type of thing is happening here. Yet it's much smaller. Well, it's probably bigger actually, but it's much more complicated because we have strike slip in here, we have spreading in here, we have a lot of subduction on three angles of it, but all that thrusting where the Cocos Plate is moving almost due north, based on what we're seeing here at 19 millimeters a year, because of the the Andes Plate and the South American Plate moving at 32 millimeters a year, shoving it north, and Nazca is disappearing as it glides underneath the North Andes. Hulking earthquake, possibly. Okay. I don't know what you mean by that. Help me out there, buddy. But anyway, so you can continue. I just thought I would add the so people understand this purple line here, which is that's the convergent, right?
Yeah.
The green is the strike slip, and the red is the divergent. We're pushing away or spreading apart.
Yeah. So the Panama microplate is moving northward in relation to the Caribbean plate. Its ongoing collision with South America occurs at a rate of approximately 10 to 20 millimeters a year. So it's not moving quite as fast as what
right
the North Andes and South America is, but not too far off. And we've already read a couple articles about it already. I'm just going to read the study summary here. Initial geological studies of Central America reveal structural and stratigraphic differences between the northern and southern regions of the Panama Plate. Later studies grouped the regions of Honduras, Nicaragua, El Salvador, and portions of Guatemala onto the structure termed the Chortis Block. So I mentioned that a little bit before, but now this is like a whole separate plate. So Panama is a whole separate. Before they thought they were all together. Farther south, the remaining portion of Central America was observed to have similar yet distinct geologic characteristics from the Chortis Block. This region, subsequently termed the Panama microplate, has since been subdivided into two separate but geological similar tectonic blocks, the Chortega and Choco block. So they've even divided it down farther, but we're not
Sure.
worry about that because that's what we have to do, right? Like breaking it all up into different things.
Well, the geological settings, it understanding where the plate is and and that it's a microplate and that it's running at 19 millimeters and which direction. I think it's important with our studies that we've been doing on the way earthquakes traverse the world. It's not so much really earthquakes that traverse the world, but that stress. And as that stress gets to an area that's already accumulated amount of stress, that it breaks, and that's when we have earthquakes. So the earthquake is actually revealing the plates moving. It's actually revealing where there's subduction zones and the thrust faults and stuff like that. It really shows that our planet is really alive and it's doing things. And that's why I think what we're doing here is really important to help clarify our hypothesis that there's quakes are following certain patterns, and they continue to follow those patterns because the way that particular plate's moving, and it interacts with other plates, and that's why we get interplate earthquakes as well, which we've been having quite a bit of them here in the States, United States, that is, and traversing across the United States. And lots of movement coming up from the south right now, seeing how we had another, 4.3 in Baja, right? So all related, interrelated, I should say. And what we're hearing right now, that noise is, I'll turn it off right now. It is earthquakes that have taken place, and is a 4-banger, I think it is. And like I said, I'll make sure that it's not on there right now. So that won't happen again for tonight. So he won't be distracted by it. So we've talked about the geologic settings. Interesting that this article here also has the 3 million age, because it was once thought that, it wasn't that old. I mean, it was much older. In the movement, in a generalized movement of let me see here. We're back at that one. Let me do that for you. There's another article here I want to bring up. Back in December 18th of 21, Stephanie Pappas of Live Science. She wrote an article about how geological secret passageways under Panama moves rocks thousands of miles away. And I think that's pretty interesting, that there's another geologic secret about how things happen. And in this article, she writes, a geologic secret passage beneath Panama may explain why rocks from Earth's mantle are found more than 1,000 miles from where they originated. The opening, located some 62 miles below Earth's surface, may allow a flow of mantle materials to travel all the way from beneath the Galapagos Islands to beneath Panama. This never before discovered form of transport may also help explain why Panama has a very few active volcanoes. On the west coast of Central America, the Cocos tectonic plate is diving down and pushes oceanic crust under the continental crust of North American, Caribbean, and plate Panama tectonic plates, a process called subduction. This subduction zone creates a line of volcanoes called the Central American Volcanic Arc, where lava pushes through the boundaries, and but the volcanism stops in western Panama, which it sits on the Panama plate. A postdoctoral scholar, David Beckhart, um, it found out this, and he says the relative peace has long been a mystery. Now, Beckhart and his colleagues have a new study published in November 23 of the Proceedings of the National Academy of Science. And it's kind of interesting. High helium in central Panama reveal a distal connection that's kind of a sideways connection to the Galapagos plume. He says he wrote it in his report. He wrote a discovery of anomalously high helium in the cold geothermal fluids of central Panama, far from any active volcanoes, combined with independent constraints from lava geochemistry, mantle source geochemical anomalies in South America that require a Galapagos plume contribution that is not derived from the hotspot tracking recycling. Instead, these signals likely originate from a large-scale transport of the Galapagos plume material at the sublithospheric depths. Mantle flow modeling and the geophysical observations further indicate these geochemical anomalies could result from the Galapagos plume influenced asthenospherically by the mantle wind, that is, actively blowing through a slab window beneath the central Panama. The lateral transport of the plume material represents a potentially widespread yet underappreciated mechanism that scatters enriched geochemical signatures in the mantle domains far from the plumes. So Eden once brought up the idea of a window, a slab window. This study talks about that. And it is well established that the mantle plumes are the main conduits for upwelling geochemically enriched material from deep in the earth, its interior. The fashion and extent of which flow processes at shallow depths may disperse enriched mantle material far from the greater than 1,000 kilometers from vertical plume conduits. However, remain poorly constrained. These remain poorly constrained. Here we report helium and I think C is what, calcium, isotope data from 65 hydrothermal fluids from the Southern Central America margin, or the CAM, which reveals high helium 3 and 4 up to 8.9 rads in low temperature below 50 degrees Celsius. Geothermal springs in central Panama that are not associated with active volcanism. Following radiogenic correction, and these data imply a mantle source of helium greater than 10.3 RAs, potentially up to 26 RAs, similar to the Galapagos hotspot lavas, markedly greater than the upper mantle range of 8 to 1 RA. Lava chemistry. I know there's a lot of letters. Let me get through it. PB isotopes and MBU and all these other geophysical constraints show that high helium values in central Panama are likely derived from the infiltration of the Galapagos plume like mantle through a slab window that opened plus or minus 8 million years ago. Two potentially transport mechanisms can explain the connection between the Galapagos plume and this slab window. Sublithospheric transport of Galapagos plume material channeled by lithospheric thinning along the Panama fracture zone, or active upwelling of the Galapagos plume material blown by the mantle wind toward the Central American margin. So there's the window. So they're kind of saying, hey, remember, there's a window also at another triple junction. We have yet to talk about a triple junction in this area. But having a slab window leads us to say, could there be a triple junction in this region? I'm assuming there is one. You have the Nazca plate, the Cocos plate, and the Caribbean plate. 3 plates, there's a triple junction, right? So if there's and we've studied other articles that said where there's a triple junction, often it creates a slab window, which is meaning one subduction area is not there. The plate that's supposedly diving down underneath doesn't exist. So that's called a slab window. Like what's happened up in Northern California, the Mendocino triple junction. There's a slab window south of the Mendocino junction in California, probably, I think, 100 or so, 50 to 100 miles along the coast, just below Mendocino there, where on the shore there, that is. And it has different tectonic anomalies with earthquakes or lack thereof, volcanoes or lack thereof, and upwellings of different materials. And that's what this article here that this guy wrote. And it's interesting that underneath Panama, there quite possibly could have a slab window. Yet it's its own plate. So I think that's kind of interesting.
Because if you study like triple junctions, there's always a plate that forms at the middle of the triple junction.
Right.
So what they're suggesting here is that the Galapagos hotspot made the Panama microplate, and it's probably still connected to it somehow underneath. That's what they're trying to say.
Very well could be.
So it's the same as them saying Yellowstone hotspot made Silesia. So now they're saying the Galapagos hotspot made.
Yeah, man, it'd be easier if they just came out and said it, though, right?
Because this is what they do. They're just copying everybody else. If you go and once they start studying, they're comparing it to all the other areas. So then they make some big article and they could just say the same thing. But that's not what they do.
Yeah, in the article,
like they're trying to make it out as some super special thing when it isn't.
Right. And this slab window, kind of like opening in the Cocos tectonic plate that's being pushed downward toward Earth's center. The scientists, or these people who wrote the article, are trying to understand more about how the subduction works near Central America. The subduction of the Cocos plate under North America has the capacity to cause large earthquakes, including the 2017 Chiapas earthquake, which we hear about Chiapas all the time, right, everybody? Almost every day we have a Chiapas earthquake, but an 8.1 that happened in 2017, right? Killed a lot of people.
Well, you're going to see this area was acting up before that. But
yeah. And to learn more, the researchers delved into the geochemistry of the region, collected volcanic rock samples, as well as gas and fluid samples from hot springs. They were interested in looking at ratios of molecular isotopes, which are variations of the same atoms, which differ numbers of neutrons in their nuclei. In this case, the researchers were particularly focused on the isotopes of helium and lead. Different sources, geological material typically have different compositions, so we were tracking the combination from different regions of the mantle. That's what Becker told this article here. The mantle is made up of silicate rocks, which are rocks with particular structure of silicon and oxygen atoms. But the precise composition can vary a lot over even a small distance. The researchers found that there were some strange anomalies under Central America. We found that particular place of Central America, namely Western Panama, and behind the volcanic arc in Costa Rica, we have some exotic signatures of geochemistry that really resemble what you have in the Galapagos Islands. So they're seeing some similarities here between what's happening over there on the border of Panama and Costa Rica behind the volcanic. It's the other side, right? The eastern side. And the Galapagos, which is, near 1,000 miles away. So it's like, what? And that's where the blowing in the mantle wind has come from. So this was a strange because there's no clear way to explain how the mantle elements from the Galapagos Islands could get all the way to Panama. The researchers then turned into seismic imaging in the mantle, which uses earthquake waves to map what's beneath the surface. We've heard about this, right? Many of us have. The computer modeling to try to explain what's going on. They found that deep beneath Panama, the buried portions of the Cocos Plate may hold an answer. When the tectonic plate slides under another tectonic plate during subduction, that subducting plate doesn't just disappear. It retains its structure as it grinds down into the mantle, only gradually heating and warping. Just beneath Panama, there is a hole, a window through the slab that allows for the influx of this mantle component to rise up. This window may be the result of a natural pre-existing fracture in the subducting Cocos crust, or it may be a place where the crust snapped during the subduction. Either way, it lets material pass through from one side of the plate to the other, like a breezeway through an open window. That left the question of what might be driving the breeze, right? So they know there's this movement of material. What's making it happen? The researchers found two possibilities. The first is the materials are moving through the Panama fracture zone, a zone cracking in the crust and upper mantle that connects the Galapagos to Panama. But it's different to see that what would be driving through a long distance transport through that zone. It's not clear whether the transport is even possible. More likely scenario, though, researchers have found is that the typical large-scale circulation of mantle simply drives materials through the opening in a subducting slab. When we have done the modeling of the mantle circulation in this place, you expect to see deep global mantle flow. The existence of mantle window can also explain that the lack of active volcanoes in Panama. Where in South America do we also find another area where there's no volcanoes? A huge portion from Ecuador to all the way to southern Peru. Ecuador stops. That's where the volcanoes stop. A lot of Peru has no volcanoes until you get to the south by the armpit. It's very interesting. Water locked into the crust subducting slabs tends to promote the formation of volcanoes because water lowers the melting point of rocks, leading to the formation of magma. The opening of a slab under the Panama means there is a gap in the water-rich crust in that spot, which in turn means it's harder to get melty magma flowing there. The mantle flow, the team discovered, is understudied, though. But there are unexplained anomalies as well in the chemistry in the mantle all over the world. His team hopes to conduct a similar analysis in Chile next, but ultimately wants to expand the method around the globe. No one's been thinking about the process before this particular process. So I want to consider all the data. So they're trying to find out what is pushing the material through. Is there a flow? Many of us here at JSL believe that there is a flow. And that flow has evidence by electromagnetic movement. And that flow has evidence of plate tectonics moving. That flow has evidence of earthquakes traversing along a certain line of what we call lineaments, magnetic lineaments, electromagnetic lineaments, sorry. So that's what's interesting about these articles in combination. And I think it's a great transition into what Canuck has in force. I mean, we can talk about the Columbia connection and then get into the earthquakes, or if you want to do that, Canuck.
No, we'll just start with the earthquakes now, and then
Yeah, and then we could bring that in after the fact. So, do you have a link you want to work with?
Yeah, I have it ready.
All right, you have it ready.
So we're going to look at the list of quakes in Panama and then see what happened after.
All right.
Like what we do.
Yeah.
Basically
right.
what we did last time, except this shouldn't take as long because we.
Okay, I'll let you go ahead and lead this one. So because you want to bring out certain ones.
Yeah.
Should I put back up there the Panamanian picture?
Yeah, just keep that up there. Yeah.
All right. Go ahead.
So this list that I have, what they're doing is showing the ones that made limited, moderate, or extreme damage in Panama, Costa Rica. So that's the list here. That's what they're showing. So there's a bunch in this list. It starts with 2009, July 4th. They call it the Panama, Costa Rica earthquake. So it was a magnitude 6 with intensity 5. 32 people injured, limited damage. Now, because I have all the dates pretty much memorized for all the big quakes in like California or the West Coast. Well, this was the middle of 2009, but at the start of 2010, we had the Baja quake. So this would have been like, well, it would have been 5, 6, 7, like 8 months before. So it was acting up down Panama, Costa Rica within a year of the 2010 Baja quake. So then I looked at the next one, and the next one they had in the list here was 2004, February 4th, which was another one. They called it Panama, Costa Rica quake, 6.1. Says very many injuries, but limited damage. Mm-hmm. So similar to the one that was.
So they're happening in a specific area. Is that what you're saying?
Yeah, they list them a bunch that are close to the border of Costa Rica. They call them Panama, Costa Rica, both. Okay. And then in this list, if it's closer to like a certain place in Panama, then they list the name of the place. But if it's close to the border off the coast, they call them Panama, Costa Rica, which is why you have to look up. But we're going to look up the specific Costa Rica ones after.
Okay.
Yeah. So then the next
you're trying to build a supposition of saying that there's a boundary somewhere in Panama, Costa Rica that along that border that has major earthquakes that is evidence of something happening there.
Yeah.
The convergent.
So the next one they have on the list is 2004, February 4th. And they said very many casualties, but limited damage. Then the next one they have is 2003, right at the end of the year, December 25th. Puerto Amulas, 6.5.
Amuelas, yeah. That's basically in the Panama Canal
Yeah.
at the opening on the
10:37.
Pacific side.
2 deaths, 75 injuries, moderate damage. Then
The
the next one,
6.5, yeah.
yeah, then the next one they have is 2002, July 30th.
I don't know where that Barica Peninsula.
Yeah, Barica Peninsula, 6.5, intensity 7. So very
Oops,
similar to
sorry.
the previous one.
Yeah, that's a little bit north of, yeah. It's on the border of Costa Rica and Panama again. Yeah.
Pretty close.
Share this tab. Okay, it's right there. Right, everybody? So you understand where this earthquake is right there. I'm trying to get you as much information as I can.
Yeah. So the next one they list is 2000 November 8th. This one must have been, because it says Panama, Colombia, so it must have been closer to the border with Colombia, 6.5. Some moderate damage, it says. So early 2000s, it was acting up quite a bit down there.
Yeah, I can see that. And Panamanian, Colombia, we talked about several of these in our last discussion, where it's not so much in the mountains, but in the lowlands of the ocean side or the Pacific Ocean side of the Cocos Plate, Panama Plate, and Nazca Plate, and in the lowlands there of Panama, that there's this pressure that's happening between Colombia and Panama. And that's what we talked about last time. So it's amazing that we see another one, November 8th of 2000, Panama, Colombia. You want to go to the next one?
Yeah, then it's going to the ones that starts giving ones in the 1990s. So
right.
The first one is May 4th, 1991, Bocas del Toro province, 6.2.
Right. Now that's in the north, the north border with Costa Rica on the Atlantic side.
Yeah. And then it gives another one for that year. On April 22nd, Costa Rica, Panama, 7.7.
Wow.
Which we remember this from our study about where the 1992 quakes came from in California.
Right, so right. We watched that, eh?
Yeah, this would be the year before. So that one was seismic intensity 9, so it's pretty big.
Yeah, 7.7 extreme damage. Yeah. Excuse me. A lot of deaths. Known as the Limon earthquake or Bocas del Toro earthquake. Occurred at 3:57 a.m. on April 22. 7.7 earthquake was in Pandora, Valle la Estrella, in the Caribbean region of Limon, Costa Rica, 225 miles or kilometers, 140. 140 miles southeast of San Jose. Earthquake was the strongest recorded in Costa Rica's history and was felt throughout the country as well as Western Panama. So it was on the border, where the last one hit. We talked about the Bocas del Toro, the 6.2. That was in 91. The 7.7, it was prior to the other one. So the 6.2 was an aftershock that occurred in Panama, but on that border. So this one occurred April 22, and the other one occurred May 4th. So the 7.7 happened first. They have it listed second after the fact, but I don't understand that. That's what's throwing
Well,
us
they're
off.
listed in chronological order by damage, I guess.
I guess. Yeah. Oh no, chronological order. No, I don't know why. You're right.
Yeah, by damage. I think it's because they're doing it by damage.
MMI. I think they're doing it by MMI. No, they're not. Wow. They must be whatever. So the Bocas del Toro happened after the fact. The Costa Rica Panama 7.7 happened in 91. I remember hearing about it. A massive quake. So much was going on. And then a big 6.2 happened the next
And you
month.
have to remember this year
Couple
we've
weeks.
had Panama acting up to sixes. So I'm just throwing that in there right now.
Yeah.
With this next one, 1983,
Mhm.
April 3rd, Costa Rica, Panama, 7.3. Well, that's the same year as the Coalinga quake in Bora Peak, Idaho.
Yeah.
So that's pretty interesting.
Often I will relate to our listeners the connection with Costa Rica and North America, especially interiorly as well as along the coast. A lot of times when Costa Rica goes off, we see Texas's pounce all over the place. There's some sort of something that goes from Costa Rica right into West Texas, and it really shakes West Texas on the seismos anyway.
Yeah.
Before it even shakes Mexico, it's crazy. I mean, it'll start to move way through Mexico, but Texas is, just weird.
Yeah.
Okay, that's 1983.
So now the next one is 1941, December 5th, so right near the end of the year. Costa Rica, Panama, another big one, 7.6.
And that one created a tsunami as well.
Yeah.
So that's close to, I don't know where that location is. They don't have it, but maximum Mercalli is a level 4, so it's not a particularly strong, but many injuries happened, 6 deaths, and it was a 7.6, 1941. Now, we talked about the 1940s. Not too long ago.
We just never went back to 41.
And I'm sure we talked about the 7.6 that took place.
I don't think
and how it moved.
I think we went to 43 or 42. But
you're right. Maybe we didn't go to. Well, we've done the 40s before.
Yeah. So if we would have went to 41, you would have been adding this one in.
Absolutely.
Because it was right at the end of the year.
And a lot of our shows kind of overlap each other. So watching or listening to the shows, you'll pick up kind of the gist of what's going on. We kind of went into it pretty deep here a couple of weeks ago, where we showed evidence of movement across the entire Pacific Ocean, all the way from Turkey, basically, through the Mediterranean, through the Atlantic, into the Mid-Atlantic, and then coming in through the Central America and South America, and then revealing itself in North America, and then moving west. And
so what we're doing now is the component coming from the south.
Yeah,
the big ones on the west coast,
right?
North America.
So this is just a little snippet of how movement's working, without getting into too much detail.
Yeah. So
in
now
1934.
July 18th, 7.7. So another big one. Only 4 injuries, though. Limited damage, but another tsunami. So crazy. And 1934 is the same year that you had all the crazy quakes in Nevada. Because I remember that from studying the Nevada quakes. So this all would have been the same year. And there was all the crazy stuff going on 32, 33. Because you had the big,
Yeah.
3 big quakes.
Long
32
Beach.
in
Long Beach
Mexico.
popped off. Yeah.
Yeah.
Mm-hmm.
And all that stuff.
7.7. That's crazy, dude. Another
Yeah.
tsunami took place. It was in Panama Costa Rica border. So what is that? A little less than 10 years between those, but then there was a 40-year wait from 41 all the way to 83.
Yeah.
And then there was a less than 10-year wait. And
Well, I'm going to show
then there's
like
another
the
10
Costa
years.
Rica
Yeah.
ones next. Well, there was a 6.7 a week before Ridgecrest off Costa Rica. So in
Yeah.
2019. So it went Peru, Costa Rica, then boom,
Mm-hmm.
Ridgecrest.
Yep. Peru big
So-
8.1, and then
So that's how it worked back then. Now, just to show you, they have 1882 on here.
at
September
8.3.
7th, wherever the sand.
That's on the northwest side of Panama. It's little islands right off the north, just north of where the Panama Canal is. So I looked that up so I can tell you
So
where
they
that
say
was.
that one was an 8.3. Seismic
Crazy.
intensity 11. Severe damage. And this is another reason.
And another tsunami.
Yeah. If you study the faults in Panama, they talk about this one because they're worried it can destroy the Panama Canal, which Mexico would be happy.
Yeah, which Mexico could be happier. But they're dealing with pressure from what's going on here in Panama. Mexico is, and they're trying to make a train ride, and I don't think it's going to work too well because I'll tell you, it is so seismically active through there. I actually think that Mexico is sliding west, and part of it is sliding northeast, where Mexico is coming apart right down there. So maybe in a couple of million years, the Yucatan will not be part of Mexico anymore because there will be another waterway through there. It might, and
so Cuba will
the Gulf of America might have an opening right through to the Pacific Ocean right there. Could take 10 million years, or 3 million years, because some of this stuff moves really fast. And we're like, wow, not in a lifetime of humans, but in 10 lifetimes or 20 lifetimes, pretty far out stuff.
Yeah. So we're not going to talk about 1621.
Nah, it's just too far back.
Because we don't know what was happening in North America, really. So don't worry about that one.
I'm sure there was a 1600 one we were talking about before, but we're not going to go there.
Yeah.
All right. So what do you got? What do you got now?
I'm going to bring up the next list of the ones in Costa Rica.
Costa Rica, not Cost.
Well, I call it Costa Rica.
I know, because of the English. I know.
Because it's cheap. That's why everybody wants to move there. Same as Panama. They pay me $1 billion to go to that.
Yeah. Yeah, I don't think so. Not for me. Too many Americans died down there building the Panama Canal.
Although where Chuck lives, he says it's 70 degrees all the time because he's up in the mountains. But Panama City. So he likes it, but I wouldn't care.
All right.
I like it -40 every once in a while just to chill
out. Not that cheap anymore, she says. Yeah. All right. So we have a list of earthquakes here. And howdy. It's the same list, except for it expands. Expands a little bit. I think the other list was stopped at 2009. This list has a 2009 Chinchona earthquake, 6.1 northwest of San Jose. Excuse me. Costa Rica earthquake of 2012.
Yeah. Now this 2012 one was the same year, and it was like a month before the big Haida Gwaii quake. The 2017 one was actually just around the same time. It was about time after all the big quakes in Mexico in 2017.
Yeah, this is the Costa Rica earthquake right here. So what he's seeing is a lot of like big 7.7 and a 6.1, and then we have some islands out here, right? San Miguel Islands. We also have Gobernadora, and then these islands down here. These are all islands that are inhabited too, by the way. Big earthquakes happening right here. Also, another big giant one happened down here in Panama, near Panama City. Chorora. And what was the other one? That San Jose kept coming up. Thought San Jose is part of Costa Rica, though. I don't see it. Here's Colón up there. All right. Well, anyway. Yeah, I don't know where San Jose is.
Yeah.
But it kept coming up. But big earthquakes are happening right out here in these mountains. And this quake here we're talking about is right there. So these are Costa Rica earthquakes, right?
Yeah. So that was major ones that.
Right. Here's the Chinchona earthquake, and right here in the middle of Costa Rica. Here's the border with Panama. So along that mountain building thing here, orogeny.
Yeah.
And
now they don't have the 2019 6.7 one on here.
Right.
It's only going from 2017.
Again, looks like central Costa Rica really bangs hard. That's what I'm seeing. The Limon earthquake was a 7.6. That's right there. Right epicenter. Here's Panama. Yeah, it had the 6.1 over here. Here's Limon. Right. On the interior side, like I said. So both of these were quaking in that, 83. And then
2009 would have been
Chinchona, right. 6.1. Then the Costa Rica 2012 we saw. That was a massive one. Mercantile was a 10. 2012, that was this one here that I told you about in Nicoya.
Yeah, and that's right pretty close in time before the big Haida Gwaii, 7.8.
Right.
Up before when I was looking up 2012. Because it was like September 5th. And the Haida Gwaii one was
again,
late October.
And then another 6.5 in 2017 was right in central Costa Rica. So central Costa Rica gets hammered, as well as the border with Panama gets hammered. And when it's on the West Coast, there's tsunamis. All right. So interesting.
And then it has a 1999 one in there that I didn't know about, 6.9, which that was the same year as Hector 9.
Yeah, this one is in August. Again, San Jose, Central Costa Rica, right?
Yeah.
Here's San Jose. That must be a state. So we had a big 7 point something here and another one here, and now we have another one there. So along that western edge, and then we did have one over here as well. So it's not just that. Yeah, in 1999, yeah. Hector Mine. 96, 91. Look at that. 91.
Yeah.
That was in April. 7.6.
So that would have been like the year before all the
Yep.
crazy quakes in SoCal, 92.
Yep.
And then see, it was acting up even 1990. They have here a 5.9 and a 7.
When was the Whittier Narrows earthquake? Is that like 89 or was it 90?
I can't remember which one.
I don't remember either.
I think there was one in the 2003 or something too. There's been more than one Whittier quake.
1987.
Yeah.
All right. So it was prior to that. 1987 there.
Well, see, it's got the 83 one on there again.
Sure. Yeah.
So it was acting up again. 83 before Coalinga and Bora Peak, Idaho.
Yeah. The we talked about the Bora Peak one already.
Yeah. Now the other ones I'd have to look up. I don't remember right offhand. 74, 66. Well, they're only 5s anyway. So not super big. 1910 Costa Rica quake, that's 6.4. Can't remember anything right offhand. 1910. My mind. I know 1822 Costa Rica quake. There was a big quake in Chile in 1822. So that I don't remember about 1910. Which would have been a few years after.
Well, 89 was Loma Prieta.
Yeah.
Boy, it didn't seem like it was that long ago, right?
Yeah. Because basically, whenever I try and trace back any big quake on the West Coast from California on up, there's usually always big quakes in South America and Central America.
Well, Northridge was 1994, right?
Yeah.
How's that fit on your list?
Well, because it was doing all that stuff in 91. And then you got all the crazy quakes in 92. Right. And then if you actually look up all the stuff that was happening in 93, you can see where it was coming from to make Northridge.
Yeah, 92, Big Bear Ladders.
Yeah.
Excuse me. Cape Mendocino had a 6.6 as well in 92. Cape Mendocino had a 6.5 in 92.
Yeah, there's a whole bunch.
Cape Mendocino had a 7.2 in 92. Joshua Tree had another 6.3 in 92. I'm not talking about the Big Bear Landers quake. That was as well. So in 92, there's a whole bunch of it. The LA area, Sierra Madre had a 5.6.
Like 2 years out from whatever quake date.
Sure.
For 3 years, even that, you can see how it was working out.
Yeah, exactly.
It keeps like hitting the same areas over and over again, and then it just, you can see that it's moving up.
Yeah.
That's what it does. It's just people aren't looking for it, right? Because they don't care. They say, "Oh, I don't care."
In 1990, there was a Punta Arenas in the province of Costa Rica, a city which is comprised of Chacharita and El Roble districts. I don't know where the hell this one is. All right, Punta. Okay, it's in the bay there. That's where the tsunami hit. So, that's in 1990. And
So if we
the upland earthquake happened in that same time period in 1990. We had a 5.7.
So if we would have known this
I
long
remember that
ago,
one.
we could have been figuring all this out. But it's only recently that we're able to, like, we have all this data, but
Well, we don't know what to look for, and now we're just discovering that, right?
yeah, and now we can actually see the.
You know, there was a precursor to the Loma Prieta earthquake in October 17th, and the World Series earthquake. There was a precursor to it in August.
It wasn't.
It had a 5.4.
Yeah, 5.
So.
Yeah, if you read about it, they say that was a foreshock to it.
Yeah, foreshock. Yeah. I call it a precursor, but looking in
and back when Ridgecrest was
83.
happening, I was looking at Panama, Costa Rica back then because it was showing up on the GEMPA feed all the time, like crazy, same as like SoCal.
In 1983, Golfito 7.2 in Costa Rica, subduction of the Cocos Plate under the Caribbean Plate. Over 51 aftershocks reported of greater than 3.6. So, 1903, pretty.
Panama and Costa Rica can get big ones.
Yeah. And we're talking, 83 there. Coalinga popped in May 2nd, 6.2. 84, we had Morgan Hill, which is up in the Bay Area, 6.2 in 84. In 86, we had pretty good stuff happening.
Because there are studies that are older from like the 80s and 90s that they were noticing that the quakes were progressing from south to north. And so when they started looking back at them, they said, why is it doing that? Well,
so if you don't see it happening in California, look over to Texas, look over to Idaho, look over to I got a list of earthquakes in Idaho, in Cali. And what about in Idaho, maybe?
The big ones I don't remember.
In Utah. In chronological, let's look at Utah. There's an 89 one. I think it was 89, one of our numbers here. There's a 90, April 28th.
90s.
What about in what the hell? In Panama here. 91, couple in 91. And I find it a little bit interesting, man, to tell you the truth.
Yeah. And then we're going to do the same thing for like Nicaragua and El Salvador and all that.
Right.
Because sometimes it hits one and jumps one country because there's all those little ones there all together.
Sure. But the progression you can see.
Yeah, you still see that it's coming up.
Yeah. Interesting how
it's just that people weren't paying attention before, right? They didn't care. They say, "Oh, I don't care."
The Limon, what happened in April 22 of 91. Utah had in 89 January had a 5.2. If I don't see something in California, I look to some interior states, because what we've seen is there is a separation. Sometimes the quakes go inland, sometimes they go up the coast. Why that happens, I think it has to do with the chicken leg my theory of the chicken leg, pushing it one way or the other. Um, and it's always the mechanism of how these quakes traverse, whether they're interiorly or whether they're going up the coast. I've seen patterns persist. That's why I'm bringing that up. That's why I'm bringing that up.
Because I think for like the West Coast, it's the two main things driving it are the stuff coming up from the south and the stuff coming across. So going east to west, right? That's the two main.
Yeah, the stuff out off the Atlantic boundary. Yeah, that's how I see it too. I see a push, and then there's resistance that's in the Pacific Northwest that the rest of the plate kind of morphs around, whether it be the Yellowstone hotspot and the depth of the the mantle that's in the Chalice area of Idaho, because I can see a bow that persists across United States, almost as though it's coming out of Alaska.
Yeah, and I think Idaho shakes because of Svalbard to Iceland.
You think that on that side? Okay.
Well, yeah, we'll because, if you follow how those faults are there, they go northeast to southwest, and if you keep following them across,
right,
they eventually go to Svalbard. So anything between Svalbard and Iceland is acting up. You're going to have all sorts of problems in the interior before it goes big on the West Coast.
Yeah, I'm going to share
between Alaska and Mexico.
I'm going to share another screen here with you.
And you have to remember, we had that 6.9 on the Charles Gibb fracture zone raking on his ridge here not too long ago. So so that was if you go right across east-west, it's pushing all that.
Right.
North America west.
This is just an observation that I made earlier in this week. I didn't have a chance to really talk about it, but the Chalice area is right here in the middle, and these green lines are activity that I see. It's not that it's traversing this direction, but that there's something in the middle that's holding it. Everything else is weak and going around it. Also, there's movement from the south with a bows of
Caribbean Sea, class, moderate, magnitude, 5.2, depth, 9 kilometers, 13
Caribbean
minutes.
Sea. The Caribbean Sea right there. Right? So you see down here in Chiapas in Mexico, Texas, up to Nevada, and then over here, then the yellow lines are the Texas and the Olympic Walla Walla lineaments. Okay, there are structures that, if you look at, let me bring the USGS on over here.
Guess where it is? Right off Honduras.
Yeah.
So it's not the Caribbean North America plate boundary. It's all those islands off of Honduras, whatever they're called.
Yeah, El Salvador right there, 5.4. No, the USGS does not have it yet. This is, I'm sharing this tab here.
Well, it's directly across from it. Like if you go east, from Chiapas Street to where it is.
Okay. Yeah, I mean, the current stuff that's happening right here, this is at El Salvador earthquake.
Worldwide alert. 2 new events.
No, it's doing that because I clicked.
5.4 that happened on the 18th, which is today. Also a 5.8, which is on the 18th today. All right, a 5.8 and a 5.4. Two powerful earthquakes happened along the Central American Trench, right? This is Chiapas and this is Oaxaca, Salvador, Guatemala, Nicaragua, and Honduras. This one they said was what, off Nicaragua again? Was it on the Pacific side or the other side?
No, it's in the Caribbean Sea. It's like
Caribbean
there's a whole bunch
Sea.
of islands out there. Whatever that's called, I can't remember.
Caribbean Sea,
There's a-
5.2.
Yeah, the name they give that, whatever that ridge that's out there.
Okay.
Goes up towards.
Often this is called Nicaragua. Often. Also, often, if it's a little bit more north, Honduras. So I'm going to show you, share this tab instead.
So it's kind
Right,
of funny.
right here's the,
when we were talking.
right, as we're discussing it. Yeah, because the area is important. This is not the first sizable earthquake. Uh-oh.
Oh, now I'm getting drone alerts.
Okay, another drone. Yeah. Central, just south of Galilee. Yeah. Share this tab so everybody sees this is where the drones are coming from, somewhere out there.
Alone, Hatavor Industrial Zone.
So hostile aircraft.
If there's been drones,
Dovrat.
they all get shot down, so it's not that big a deal.
Nin.
So that what's happening is every time the trajectory of it, they're seeing that it could possibly hit in these areas.
אחוזת ברק. עפולה. עד דחי. אכסל.
And so what they're doing is they're warning people, because some cocksuckers over there in Iran decide
Sulam.
to
עין חרוד.
hurt people just because. I don't know why the hate's there. I have no idea why the hate's there. I'm not even sure they know why. They just hate.
גבע. תל עדשים.
Nav Hagalo.
But I'm going to go ahead.
כפר יחזקאל. מרחביה מושב.
I'll go ahead. I closed it. So back to it here, Kanaka. So we're talking about the Caribbean Sea, Costa Rica, Panama. We'll probably go into a lot more regarding Costa Rica, Nicaragua, and Honduras the next time.
Yeah.
And then
So,
following time we'll do Salvador and Guatemala and southern Mexico. Because we should become familiar with these plate boundaries and what happens and where these earthquakes are happening. Now, this current earthquake that took place, it's well south of the 7.6 that happened. Let me see if I'll get this 5.2. I'll get the coordinates for you right here. Hold on, and then I'll share screen. Google Earth here. All right, here's the Google Earth. So the current earthquake is at this location. Get rid of that booger. Okay, so it's right out here, okay? Here's Costa Rica. Here's Panama, right? Here's the border. San Andreas is out here, little island out there, right? And you've heard of some of these other little islands. Let me go ahead.
Yeah, and I forget what that
view,
bridge is called out there. There's a name for it.
Layers,
islands
everything already there. Good. But near San Andreas here, this is Nicaragua. Often this is called Nicaragua, but they're calling it the Caribbean Sea. And wasn't long ago we had a 7.6, but it was up here.
Yeah, closer to.
But
the
we did
Caribbean.
have several other earthquakes in Nicaragua that I'm going to pull up for you right now. But just this year, and let me see here. I'm going to go 4 plus custom, and I'm just going to say use that and search.
Yeah, San Andres Island is.
And
It's
right
one
on the
part
money where the other
with
one
all
was,
the
that's where this
projects.
one is. So
Where's
let me share this tab with you. Okay, this is just this year. Here's the big 7.6, and then several aftershocks. That pressure remained there? It hasn't gone anywhere. So we're still waiting for something to happen. However, in the meantime, we have today's quake. Now they're calling it a 4.6 USGS is. And a 4.9, and they're seeing Mountain Columbia, right? Columbia, right? And then there's a 5.1 in that same area that happened in this month on the 7th, right? And this one happened in January, and this one just happened right now. Then there's this one, 5.4, the Caribbean Sea, happened in March, and then there's one right here and right next to Panama that happened in May, 4.5. And what's interesting is you see the straight line kind of relatively straight. Then we come down here in Panama at 6.2, 4.5, 5.7, right? 4.8. You can see that, right? You can see this, this generalized direction, north, south, a little bit northeast, but north, south, coming out of this.
Where that
quite
quake
possibly.
is, the Nicaragua.
Then you also see on the right hand side coming crossing the mini what do you call them, accretionary planes that we've come across.
Yeah.
Do I even have that image still? Where the accreted terrains were all there in Colombia there. Very interesting how that ties in with what's going on in the the south here.
And where that quake is on what they call the Nicaraguan rise.
It's the American Cordillera. Maybe it's in this one. No, it's not. I don't know what I did with the map. I apologize. I thought I had it
southwest
still.
to northeast at Hispaniola.
See my buddy. What is this one? Haiti's vulnerability. Yeah. We can talk about Haiti for a while. The Cayman Islands, we could talk about for a while as well, but it gets too much into the weeds, so to speak. But I don't know where that page went. But interesting, that's still hitting here. So if these things are still hitting here all year long, right? If these things are hitting here all year long, we're only 6 months, right? 6 months into this year. This should be telling you something. These here, the 6 months, right? This one here and this one here, these lines, right? Whether you want to call them at this diagonals or not, it's interesting. There's a 6.3 out there in Colombia that happened this month, right? The area of the Western Caribbean, Panamanian, Cocos, Nazca, North American plates are very, very active. Even around the other side, over by San Juan, 5.6. 5.9 that happened in February. That happened in May. And this one down here, 5.0, that happened in May. The plate tectonics is happening, dude. And it's telling us if we just have to read the tea leaves, right? Yeah, where to look. So, is there anything else you want to add to this, bud?
No. Because right
Did I
where the
lose
5.2 just happened is on the Nicaraguan rise, it's called. That's that triangular ridge that goes
I don't know if he can hear me now.
right out. I don't know what happened.
We may have lost him. He's there, but his microphone's not on.
I don't know. Unless it went mute.
He got muted out. I'm not. I'm muted. I can see. He got me thinking, Joe. Maybe Texas feels it before Mexico from Panama because of the Gulf. All the water, just thinking out loud. Yeah, it could be. Flooded girl. I think he might be muted. No, he's not muted.
I don't know what happened. Can you hear me?
You lost us, Canuck.
I don't know what happened.
You have no sound. He's sitting there looking. Well, anyway, everybody, thanks for being here. This is an hour and 40 minutes. I'm sure we'll talk here on Twitch for a little while. For those who don't know, we do a morning report Monday through Friday, 8 o'clock. Sometimes the show starts, the Joe Slick show starts before at 7 o'clock. But the morning report, which will put all the stuff into what's happening today in the last 12 hours, that will happen at 8 o'clock Arizona time. Figure it out. I can hear you, he says. Can't hear you. I'm closing up. So we also do more rabbit holes Wednesdays and Saturdays, and at 7 p.m. And we'll go for an hour and a half. So Joe Slick Live, twitch.tv/Joe Slick Live. You can find us on Rumble. You can find us also on YouTube. We've been around for a while. Hang in there, everybody. And if you have something that you want to add to one of our shows, shoot us a line at JSLDiscussion, singular, @gmail.com. Right? Thanks, everybody. Have a good night. Love you all. And remember, don't get none on you.